Hello viewers, greetings learners. My name is Tembele Matoti. I come from St. John's College. I'm actually going to be talking to you today as the Deputy Chief Marker in the NSC November exams for the Department of Education. Welcome to the Eastern Cape Department of Education broadcast studios. Today's lesson will be on climate and weather, but in particular, I want to focus on synoptic weather charts and the analysis of the weather stations. Because we often find that there is no exam paper that will not relate to those. And yet our learners often mess it up when it actually should be an easy one like that, okay? So we'll see. We'll cover this topic for your full understanding today, and we'll dissect it and be patient with each other so that we grab each detail that we need to be able to navigate our final exam. Let's go. Let's get started. Your typical weather station model will look like that, okay? Now, it will differ from map to map, from place to place, and from time to time. So this is just what I've chosen to do to be able to assist you to understand how synoptic weather charts can be interpreted, in particular, the weather stations, okay? Now here you find that there are figures, okay? There is a 32 there, and there is a 22 here, okay? And there's something else that you see here that I would safely say now it is a symbol, okay? This also is part of the weather station model. That's also a symbol. Look at that. At the moment, if you're talking to the layman on the street, he or she will see what you are saying, but will not understand it. So these are symbols. They need to be interpreted to be able to be understood by the person on the street. Look at that, okay? Look at that. So those must make sense to the marker when you interpret them, meaning you translate them from symbols and codes to something that is understandable and simple for someone who wants to know the weather at that moment, in that place, at that time, okay? Let's see if we're going to win. Okay, there we go. What are we taking home from this now? We are saying whenever you get a weather station model, it is coded, okay? So you need to interpret the code. Hence, in most question papers, you'll find a question that says, what is the weather in area X? Let's say possibly East London or Gqeberha or possibly George or Knysna or any place in South Africa, okay? We want you to be able to change the codes and interpret and make it understandable, okay? Now let's start, okay? Let's start. The 32 that you see there is actually a code, okay? It is a symbol. So how do you interpret it, okay? The 32 must stand for 32 degrees C. Now we are interpreting it. Because temperature is not only a figure, it must also have units of presentation, okay? 32 degrees C. So if you get a weather station like this, and you say the temperature was 32, we are not going to give you marks because you are giving us the code. When you interpret it, you must say the air temperature is 32 degrees C. If you say 32 C, no mark. If you say 32 degrees, no mark. It must be 32 degrees C. That is the air temperature. There's another point I need to clarify around this one, and I'll do that when I'm done with the 22, okay? Let us look at the 22. Again, the 22 there is a code. When you interpret it, you must say the dew point temperature is 22 degrees C. Again, dear learners, not 22 degrees, that's an angle. Not 22 C, I don't know what that is. It must be 22 degrees C because you are interpreting temperature, okay? At that point, I think I need to clarify something now, okay? Air temperature is not the same thing as maximum temperature, okay? Dew point temperature is not the same thing as minimum temperature, okay? Maximum temperature is not correct here. Minimum temperature is not correct here. Expanded opportunities. Let me explain a little bit on that, okay? Remember that 32 degrees C is the temperature at that time, okay? The weather recordings are taken 3 times a day, occasionally more, especially if your weather station is automated. It takes is at very regular interval, okay? Take at very regular intervals. So it will be the temperature at that time being 32 degrees C. However, if you are going to read the maxima bulb thermometer, that one will give you the maximum temperature reached on the day. It might not necessarily be 32. It might be more than that, okay? Obviously more than that because it's the highest temperature reached for the day. The same as the dew point temperature. The dew point temperature is the temperature at that time as recorded at that time. However, the minimum temperature will be obtained from the minima bulb thermometer, meaning the lowest temperature reached on that day, okay? So there's a difference here. What we are looking for here is actually the air temperature, okay? And we are looking for the dew point temperature, okay? For the dew point temperature. That one is good, okay? Let's take the next one. Wind direction, okay? That lever that you see here, that lever gives us wind direction, okay? What we know now, or at least what we should know now, is that wind is named according to where it comes from, okay? According to where it originates. So you give the name to the wind according to where it originates, according to where it comes from, okay? So in this case, the wind, let's start here. The wind will come into the weather station, okay? Into the weather station, okay? Starts from the outside here into the weather station, okay? Meaning this wind is actually from the northeast. So it is a northeast wind. It goes into the weather station, okay? Goes into the weather station. So the lever is positioned such that you can tell where it comes from and where it is going, okay? Let's read. Wind direction pointing in the direction from which the wind is blowing into the weather station, okay? I hope we have that one. So this one will be your northeast wind or northeasterly wind because we name it according to where it comes from, okay? Flows into the weather station. I hope we're good with that, okay? Now we are going to go to the round part of it, okay? Very interesting, the round part of it. And that is where you obviously have been orientated before, okay? This round part indicates the cloud cover, okay? Or it can also indicate the absence of cloud cover. Doesn't have to have cloud cover, but it shows you that I'm relating to the cloud cover, okay? So the cloud cover is indicated inside the weather station. In this case, we can use eighth or we can use the fourth, okay? So your eighth will be whatever over 8, but your fourth will be whatever over 4, okay? So you need to read. But mathematically, this means the same thing, okay? So in this case, the shaded part, this part here, okay, indicates the cloud cover, okay? Indicates the cloud cover. And this part here it means there's no cloud cover, okay? So you can see the bulk of the skies on that day had cloud cover. We will come to what happens when it is shaded only 1/4 or 2/4 or 3/4. But if you're using your fourths, this will be now 3/4, okay? And I will explain that further. Remember, here we were dealing with units, okay? Here we were dealing with units, and here we were dealing with direction. What are the units for cloud cover? The units for cloud cover are called octaves, okay? So if we were strict with the marking, you should be saying 3/4 octaves, okay? But we are not that strict on that. But please, because you have now seen the lesson, train yourself. Next time you respond, you say 3/4 octaves, okay? Let's see if you can do that, okay? Now let's go back and clean up a little bit. Clean up a little bit, because we need to see what is happening here, okay? Good. Now we have a nice, neat pad to work with, okay? So we are done with cloud cover now, okay? There we are going to be seeing a symbol. Remember, the symbol changes because the weather, the type of precipitation will never remain the same, okay? It changes, it keeps changing, okay? So this area here is reserved for the type of precipitation indicated, okay? It can be on the left, it can be on the right, doesn't matter. I've just said left here because it's on the left, okay? But it can also be on the right. Think about a situation where your cloud cover is like that, okay? And your lever is pointing that side. So all the other indications will be now on the right. But on this particular model, we are on the left, okay? So we now are going to say, what is it that you can see there, okay? There are various types of precipitation symbols that you can get there, and we will get there. Just now, this one is probably the most popular, and you all know. What is it? Thunderstorms, okay? So we are going to be interpreting it as thunderstorms, but there are many more, and I'll get to that point, okay? Now, what do the feathers do, or the so-called short lines, okay? They indicate the wind speed, okay? So the wind speed will be presented in units called the knots, okay? The knots. It is taken from a very old term called nautical miles. So we shorten it, we call it the knots, okay? So the long one here will represent 10 knots, okay? So that is 10 nautical miles. And the short one here will represent 5 knots, okay? So if we were to talk about the wind speed in this model, the exemplar that we are using, this one will be 15 knots, okay? Or 15 nautical miles, okay? Now, remember, common language usage that we have, we don't talk about knots when we interpret in real life. We're talking about speed or wind speed in kilometers per hour. So you have to be able to convert your knots to kilometers per hour. So 1 knot, okay, 1 knot equals what? Equals 1,852 kilometers per hour. So if you've got 15 knots, you just multiply that by 1,852 kilometers per hour, and you get the answer in kilometers per hour. Rich, isn't it? I hope we are gaining a lot. Easy as it is, please enjoy it, okay? Let us get our eraser so that we can clean up, okay? We will now move to another point of interpretation that we need to focus on for today, okay? There we go. How to read the symbols on the weather map. Yes, you've got quite a lot of them here, okay? I'm going to focus on those that are of common usage in the exam, that are normally found in the question papers, okay? Let us start with precipitation. Remember we spoke about this one. And we said those are thunderstorms. That one we are covered. Almost all my learners know that one, so it's okay. We are good there. However, you do get others that are going to appear in that space. Look at this one. Looks like a fat comma. We call that a symbol for drizzle, okay? Very light precipitation for drizzle, okay? And look at that. Triangle pointed downwards. The apex is pointing downwards, okay? So there's the shower. Look at that. One dot. That is for rainfall, okay? Rainfall. This one you get, but it's not very regular. That's for showers. And this one here, put in reverse, the apex pointing upwards. That is your hail, okay? Sometimes these two will also be common, okay? Your mist, and when it gets thicker and visibility is reduced, it is known as fog, okay? Mist, and then graduates, becomes thicker, reduced visibility, that will become fog, okay? Let's get to the octars now. Remember, we spoke about octars? Let's get to the octars, okay? Here you have got nothing inside the cloud cover circle. That is clear skies, okay? Completely clear on the day, no cloud cover, nothing. So that one will be 0/4 or 0/8 octars, okay? We do accept clear skies though in the exam, okay? We do accept clear skies. But the correct way of saying it, if you are treating geography as a science, 0/4 or 0/8, okay? Now, let us move. We're not going to be doing all of them. Look at that now, okay? Half of the circle is shaded, meaning you have got half of the sky, almost half of the sky with cloud cover. So that takes you to 2/4 octars or 4 octars over 8 octars, okay? That is the one that we are dealing with there, okay? We don't accept things like partially cloudy. You see, partially cloudy. We want you to be articulate and present it accurately, okay? It is 4/8, or you can say 2/4 octars, okay? And then I will take the last one for now, that is 8 octars. In this case, you hardly see anything blue in the sky. It's all cloud cover. And we accept it when you say overcast, okay? Because it is actually 8/8, or it is 4/4 octars, okay? Octars. Please get familiar with that, octars, okay? Those are the units of presentation for the cloud cover, okay? I hope we are good there. But you have to know the others, just that I'm picking on the most popular ones, okay? Let us now move to the wind speed, okay? The wind speed. Remember we dealt with 15 knots, okay? We put that away, okay? The long feather represents 10 knots, and the short feather represents 5 knots. That's 15 knots, okay? But you can have one short one that gives you 5 knots, okay? 5 nautical miles. You can have 2 long ones, 10 plus 10, that's 20 knots. But here's the dynamic, okay? One long one, second long one, third long one, fourth long one, fifth long one. No, man. There are too many of them. That is 50 knots, okay? 50 knots, we don't have 5 long ones, okay? It translates to one solid flag like that, okay? One solid flag like that. That is 50 knots, okay? That is 50 knots. So please be familiar with this. That is 150 knots. I just want to touch on something before we move on to the question papers, okay? Sometimes you find a cloud cover weather station like that, and you've got something like that. It's common in the later synoptic weather charts, okay? This one actually refers to an automated weather station, okay? Weather station. This one reports electronically to the South African Weather Services. It is not manned. There are no people who are running the weather station, okay? It is there connected electronically. So it is automated. It generates information automatically. It's got sensors in there that report directly to the South African Weather Services. Okay. Now let's look at the synoptic weather chart. We'll spend about 4 minutes here, and we'll be very, very quick. Okay. I just want you to have a good feel of what these weather stations look like. Okay. Firstly, look at that. The weather station is attached to a town. So if the examiner says, analyze or interpret the weather station of Port Elizabeth, you look at that directly. Of course, these days they'll say of Quebec, okay? Look at that, Kaapstad, Cape Town, okay? Now, let us move, let's graduate a bit, okay? Look at that. There's your 15 knots, okay? Look at that. There's your 15 knots, okay? But there are certain dynamics that I want you to look at, okay? Sometimes you get a lever like that, and the feather is not put at the end of the lever, but it is put somewhere towards the end. Look at this, for example, and that is representing 5 knots, 5 knots. So I wanted you to have a look and see the tricks involved. Look at that again, 5 knots, okay? The other thing you'll notice that it does not necessarily have to be perfectly rectangular, like right angle. Sometimes you'll have it like that, okay? Slanted a bit, okay? Look at this, slanted a bit, and that is 10 knots, okay? I just wanted you to have a feel of what is happening here, okay? Now let's move on, okay? Let's move on. Now I want us to take that. I'm trying to move from a very simple question and get more abstract as we move along, okay? So this is 2022, November, okay? I want you to look at this one first, okay? Wind direction represented by the station model. Remember, we're using the term model. Below is, okay? Remember what we said. You look at the lever first, okay? You look at the lever, and the wind flows into the weather station, okay? So this one is actually from the south, but also from the west. Remember, winds are named according to where they originate. So that's your answer there, southwest, okay? The wind direction, okay, from the southwest into the weather station, okay? So that's the direction there, okay? Now we look at the next one, 113, okay? Which one? Meaning you're given 4, you've got to choose one, okay? Of the station models below shows drizzle. Drizzle, remember that fat comma, okay? Drizzle, light precipitation. There you go. So your answer becomes A, okay? Just trying to translate what we have already to a question paper, okay? I hope we are good here. We move to the next one, okay? Look at that. Getting a little bit more complicated, but truly very, very simple questions that we need to look at. 1 mark questions, okay? Figure 2.1 is an extract from a synoptic weather map. It's an extract from a synoptic weather map showing conditions in Marion. Immediately you go identify Marion. Now you can see where Marion is on the map, okay? Write down the recorded air temperature, okay? So in this case, your recorded air temperature is 3 degrees C. Not 3 degrees, not 3C, not 3. Full 3 degrees C, okay? And then the dew point temperature, minus 2 degrees C. Those are your full answers, correct answers, okay? Full answers, correct answers. Please remember, you give us the full way of answering, including the units of presentation, okay? Now let's look at the next one. What is the wind direction experienced on the island? Remember what we said here? From into the weather station, okay? So in this case, it is from that side into the weather station, okay? Now, where is that side? That is your north, okay? And also your west. Northwest. So that is your northwesterly wind. Northwest direction. Okay? Let's look at 214. How fast is the wind blowing on the island? What are we looking for there? Fast speaks to speed. Fast speaks to speed. Okay? And speed is in knots. Okay? Let's go back there. Is in knots. Okay? Nautical miles is in knots. Okay? So there we go. We look at the feathers. Okay? One long feather, 10 knots. Second long feather, 10 knots. Short feather, that gives us 5 knots. 10 plus 10, 20 knots, plus 5, 25 knots. So that is the answer. 25 knots. Easy. Remember, you can go back and, for practice purposes, just convert that to kilometers per hour. However, we accept this in the exam as the correct mark. So it's not really necessary to convert it, but I was giving it to you to make you understand. Okay? Now, write down the air pressure on the island. Now, this one is not really part of today's lesson, but as a learner who is revising and getting ready for exams, I'll tackle it. Okay? Look at this. That is your isobar, and this is your isobar. Okay? The isobaric reading here is 992 hectopascals. And this one here is 996 hectopascals. Naturally, when you look at the position of Marion, it is between the two isobars. So we will accept 994 hectopascals because it is between the two. So that one becomes correct. Okay? And then you take the next one, describe the cloud cover. Remember, everything there is shaded. So that is 8 over 8 octaves, or you can say 4 over 4 octaves, or you can simply say overcast. Okay? We accept that. Okay? And then we look at 217, which is the last one. Okay? Type of precipitation experienced on the island. Okay? Type of precipitation experienced on the island. Remember that dot. That dot shows you rainfall. Okay? Rainfall. And remember we said it keeps changing. It can be rainfall as you see here. It can be drizzle as you see here. It can be something else here as you see there. Thunders, or it can even be fog. It depends. But please make sure you are familiar with the symbols. Okay? We'll take the next one very quickly. We will start here. Now, I want you, for practice reasons, dear learners, for practice reasons, I want you to look at this example I've been giving all along, that of Port Elizabeth, okay? And understand that you have got all the weather elements illustrated there, okay? Look at that. Air temperature. Look at that. Dew point temperature. Look at that. Precipitation. Look at that. Cloud cover. Look at that. Wind direction. Lastly, look at that. The wind speed. Okay? So all this information is very, very important. Yes, the examiner might not need all of it, but make sure you know everything. Maybe that will give you 3 marks, 4 marks, possibly 2 marks. Please don't feel bad about it. 2 marks is also good to go. Let's look at the last one to wrap up our presentation. Okay? The station model, generally associated with a cold front. What is it? Okay? Let's go there. Let's go there. That's your mature stage of your mid-latitude cyclone, and that is your cold front. Okay? And there's your wind direction. Okay? There's your wind direction. You know that. Okay? So your cold front here is pushed by cold air. Okay? So if you were to look at the direction of the air behind the cold front, it is like that. Okay? Behind the cold front. Okay? So that is the one you're looking at. Remember, it matches with that. Okay? Also remember the cold front got heavy cloud cover along the cold front. So that is your overcast skies, okay? And the wind is fast, and that is your 30 knots. So that one, A, matches your answers correct. Perfect, okay? Dear learners, we have come to the end of our lesson today. I hope you understood it perfectly. You can leave your questions on the comments box. Don't forget to leave the name of your school so we can give shout outs. There are many lessons that you'll find there. They'll assist you with crafting your future by passing well. Thank you for watching. See you next lesson. Good luck for your exams. Please share, recommend, and subscribe to your YouTube channel, which is YouTube channel ECDOE Broadcast Studio. There are many lessons there that you will find, and those lessons will help you with crafting your future. Thank you for watching. See you next lesson. Good luck for your exams. Remember how we always sign out. The warmer the blankets, the colder the future. Please study hard and good luck. Thank you.